Okay, so we talk about the hypothesis testing in this chapter. So at the end of the last class, we discussed about this one-sided or two-sided test. So usually, in either cases, I mean, in most of the hypothesis testing, the null hypothesis that the enemy is claiming has a specific information about the parameter. So for example, so this null hypothesis is claiming that this data of our interest is specifically the same as a particular value of data 0. Okay? But in the case of this alternative hypothesis that we want to claim, that may not have the specific value, and thus it may be represented in this inequality. Or it could be just like this. Simply saying the parameter theta is not the same as like the particular value of theta 0. So usually in this case we have so so in the hypothesis testing we actually discuss, or we have to judge, or we have to decide whether we can claim that this H0 or the null hypothesis is false. Okay, so the issue is the task is to determine whether to reject or may not be able to reject this null hypothesis, right? So if the observed theta is sufficiently far from theta 0, so for example, the enemies claim that the average height is 170 centimeter, but our claim is that, okay, that is not true. Theta is not 170. In this case, in order to be able to reject this hypothesis, the theta can be either smaller or larger than 170. So there are two possible cases. As long as the observed theta is sufficiently far from this theta 0, or the value of a null hypothesis. So in this case, we call it as two-sided test, but suppose our claim is something like theta is greater than 170 centimeter. So in this case, we are specifically claiming that theta is greater than a previously believed value, or the null hypothesis value. So in this case, if theta is, for example, the observed theta, or our estimator, or our statistic, is shown to be 168. And then even though this value is quite different from the theta 0, right? But in this case, since this observed value is definitely not greater than 170, so in this case, we cannot reject this null hypothesis, or the enemy's claim. Okay, so in this case, we call that as a one-sided test. Okay, and then the next one is this p-value. So this p-value is quite an important part. So if we remember, let's see. So if we remember like this figure, then what was this blue region? So this blue region is those regions that allows us to reject the hypothesis, the null hypothesis. So the null hypothesis is this mu is like a 68 kilogram. Okay, and then if the observed mu value is sufficiently far from this 68, and then those regions are okay. So those regions are allowing us to reject our null hypothesis, but how we exactly determine this threshold is based on our level of significance. So we can allow, we allow you to say say the wrong thing. I mean, we allow you to wrongly reject the hypothesis with the 5% of the probability, and then we distribute this 5% of the probability to either side in the case of a two-sided test. So this is definitely a two-sided test. And then in this case, these values, 69 or 67, is determined based on that specific value of an alpha, right? So if alpha is smaller, so for example, your boss is allowing smaller probability of wrongly rejecting the null hypothesis, and then maybe, for example, okay, I will only allow 1% of saying the wrong thing or wrong rejection of the hypothesis, and then this alpha value will be smaller. I mean, the region for those blue regions area will be smaller, and thus this critical region or this threshold will be larger. I mean, the bigger or more away from this mu value, right? So this threshold is determined based on our alpha value, okay? But after deciding this specific alpha specific parameter or this boundary value based on this alpha value, what we do next is that suppose mu was shown to be 70. So the actual observation is saying that the sample mean is 70, and then we determine whether this value is inside of our critical region or not. So if it is critical region, and then that's when we can safely reject our hypothesis, although we allow 5% of the wrong rejection, right? So that's what we typically do in the typical hypothesis testing. But there is a slightly different scenario. So in the second scenario, we do not specify alpha value. Okay, so your boss is no longer saying, okay, so you are only allowed to have 5% of the wrong rejection. Okay, so that is not the case. So we are not given this alpha value in advance. And what we do is to use p-value. Okay, so using this figure, so let me see if I can clean it. Yeah, suppose we observed the 70 kilogram, okay, and then when alpha is 5%, and then this is within the critical region, right? But again, in the second scenario, we are not specifying in advance this alpha value, so we do not have this specific boundary, okay? Instead, we compute this. So we now assume that our boundary for the critical region is actually our sample mean value from our observation. And then suppose we obtained 70 kilograms as our sample mean. And then we consider the alpha value when this alpha was computed based on this threshold value that as what we obtained. Okay, so this 70 kilogram is a different that value will change as we obtain different samples, right? And then we set that exact value as our threshold, and then compute some similar measure like alpha, or what is the probability of getting those 70 kilogram or more, or like in the case of two-sided test, or 66 or less. Okay, so it means in this case, the corresponding alpha value in this case is called the p-value, and that p-value has the meaning of the probability of observing our observation, like 70 kilogram, or more extreme values. So more extreme means more rare values, rarer values, right? So in this case, which value is more rare to observe? It's definitely like a 71 is rarer than observing 7, right? So 71 is definitely included in rarer values set, right? So considering all those rarer values, then our actual observation, and then considering their probabilities of wrongly rejecting the hypothesis, okay? So still the meaning of alpha and the p-value is the same, okay? The probability of wrongly rejecting the null hypothesis, but the how we compute this alpha or p-value, I mean, in the case of p-value, it is purely dependent on our specific observation, okay? So, let me ask, hopefully, some simple question. Yeah, when alpha was 0.05, and then the threshold, yeah, suppose, yeah, let's assume that when alpha was 0.05, and then threshold was 69 or 67, okay? Then in this case, it's like mu is 67 or 60 or 70, okay? And then suppose mu was, I mean the sample mean was 69. In this case, would p bigger or smaller than alpha or 0.05? I mean the question is whether p is bigger than 0.05 or smaller than 0.05. Would it be bigger or smaller? So when you observed this mu value as your sample, will it be bigger or smaller? So this is your observation. Yeah, let me correct it. So it should have been 69 based on this figure, because we assume that 67 or 69 is the threshold value when alpha was set as 5%. And then suppose you obtain 68 kilograms as your sample. So in this case, p-value is, so how we compute the p-value will be, so our threshold is set as here, and then this range, and then this range. So the p-value will be the sum of these two regions, which is definitely bigger than 5%. Okay? So p-value means, given your sample mean, what is the probability of wrongly rejecting the hypothesis, right? So if p-value is relatively large, so suppose p-value was like 30% or 0.3, and then it's quite likely to obtain this sample from this null hypothesis distribution. Okay, so that way we cannot easily reject it. Okay, so instead of setting alpha in advance, based on the computation or based on the value of p computed from your actual sample, you can actually judge whether you reject or not your null hypothesis. Okay. Okay, so yeah, this is one aspect why I don't like this book, because the definition doesn't seem to make much sense. So let me just quickly search for p-value and then look at the definition of this p-value. You see, the probability of obtaining a result equal to or more extreme than what was actually observed. Okay, so here the assumption is still null hypothesis. Yeah, we are assuming the null hypothesis is true. So that is assumed to be our underlying probability. Okay, in that case, yeah. So that way we can understand the definition of this p-value. Okay, so instead of using fixed alpha, how we use this p-value in our hypothesis testing is as follows. So yeah, of course, we set up this null and alternative hypothesis. Yeah, so this is the fixed scenario. So we first fix this alpha in advance, okay? And then depending on our sample statistic is belonging to our critical region or not, which is determined based on this predefined alpha. So that's how we perform this hypothesis testing. But in the case of significant testing, which uses a p-value, we set these two null and alternative hypotheses, and then compute this sample statistic, and then compute this p-value, and then looking at this p-value, we kind of decide later whether to reject or not reject the hypothesis. Okay, then the actual hypothesis testing is almost the same as the interval estimate. So here we assume that the hypothesis or the null hypothesis is mu is mu 0. Okay, so suppose this one was our previous belief or common belief that we want to reject. And H1 is mu is not mu 0. So in this case, the sample mean is following the Gaussian distribution. So we can use this standard normal random variable z. Yeah, and then perform the hypothesis testing just as what we saw in the earlier case. So this is a standard normal random variable. So, and then these values are the threshold values for our critical region. And also again, the definition of the critical region is, so if you, so again, I'm trying to make you guys memorize the meaning of these terms. So the critical region is the regions that allows us to reject the null hypothesis. So that's the meaning of the critical region, and then this boundary point or this threshold value is called critical value. Okay, the value for critical region is called critical value. Okay, and then in the case of p-value example, and then this case is, so we see just one-sided test here. So H0 is mu is the same as mu 0, and then H0, H1 or alternative hypothesis is, so let me ask the last question in this class. Would the null hypothesis be that the mu is greater than mu 0 or less than mu 0? So which one is true between them from looking at this figure? So it means, so we obtained mu as, or sample mean as 2.02, and then the p-value is computed only on the right side. So in this case, which one is true? The first or the second? First. Second. Okay. Until you guys give an answer, I will not end the class. Okay, the first one, just to make a guess. The second? Okay, so the first one, because when the actual mu was observed as a larger value, so that's when we can reject the null hypothesis. So if the critical region was shown as the right side, then it means our alternative hypothesis is on somewhere on the right side. Okay, so that's it for today. Then we'll see you next Monday. And then also the homework is out, and then as you guys can expect, there are a lot of exercise problems, so please prepare for it in advance. Okay, thanks. 아 저기 오영현이라는 학생 있나요?
네. 죄송한데 한 가지만 얘기하게 좀 들어주셨으면 좋겠어요. 전산수학 수업을 듣는 학우 여러분 반갑습니다. 저는 정부대학 3대 부학생회장 최병주입니다. 다음 주 월요일인 11월 28일 낮 3시에
그러니까 알파가 정해지면 알파가 5%다 그러면 이게 스탠더드 감시하면 이 부분이 2.5%가 되는 그 값을 찾잖아요. 그래서 그게 이미 결정이 되어 있고 그래서 그 값이 아까처럼 뭐 69kg, 67kg 이렇게 나눠져 있어요. 그렇게 되면 어떤 값이 정해지면 어떤 값이 샘플민으로 나오면 그게 이쪽 안에 들어가는 이 안에 들어가는 이렇게는 이제 이걸 하잖아요. 근데 거의 똑같은데 p-value는 뭐냐면 알파가 사전에 정해지지 않고 우리가 본 값이 우리가 관찰한 값이 예를 들면 68.5kg이 나왔어요. 그러면 그게 우리의 크리티컬 리전의 바운더리가 될 때 그때 알파 값에 해당하는 그 프로바빌리티가 뭐냐
28.5가 나와.
그게 바운더리가 될 때 해당 알파 값이 뭘까요?
박근혜 퇴진 결의입니다. 박근혜 정권의 추악한 비리가 연일 폭로되고 있음에도 청와대는 퇴진을 불가하다고 말합니다. 범죄자가 청와대에 앉아 있습니다. 우리에겐 군부 독재에 맞서 목숨 걸고 싸워 민주주의를 쟁취해낸 자랑스러운 선배들이 있습니다.
네,
선배들이
이름이
남겨주신 자유,
어디 있나요? 여기 몇
진리란
번이에요?
이념에 부끄럽지 않게 살아갑시다. 11월 28일 학생총회에서 박근혜 퇴진을 결의하고 박근혜가 퇴진할 때까지 함께 싸웠다. 11월 28일 학생총회에서 나라의 주인은 우리 시민임을
뭐예요 이름이?
둘째, 미래대학
어디
대회가
있어요?
전면 차례입니다.
아,
미래대학은 한 학기 등록금이 750만 원인 단과대학이자
네.
전 과목 패스페일 제도 및 구성원 필수가 있고 등 모든 특기와
좀
특권을
늦어가지고.
독점하는
네,
단과대학입니다.
정승.
지금 등록금 전국
어디
1인 대학이 고려대 의대로 학기당 600만 원이 조금 넘는데 그것보다 훨씬 비싼 단과대를 만들겠다고 합니다. 그 대가로 전 과목 PF 제도 도입과 전원 기숙사 입주를 주겠다고 합니다. 이게 학위 장사이지 뭐겠습니까? 당국은 한 달도 되지 않은 기간 동안 제대로 의견 수렴도 하지 않은 채 자유정